Uno de los sistemas de monitoreo de rendimiento para cosechadoras, utilizado por firmas de primera línea, es el que se basa en sensores ópticos que permiten la medición del volumen de grano. Sobre el tema, conversamos con el ingeniero Peter Nelson, de la firma inglesa RDS, creadora de este tipo de equipos.
Okay, my name is Peter Nelson. I'm the Engineering Director of RDS Technology. We're based in the west of England, and we manufacture a wide range of electronic instruments for farm machinery and also for industrial machinery. I'm very pleased to have been asked to present what we know about precision farming here today. Basically, we will talk about RDS's entry into electronics for agriculture and how our precision farming systems have evolved, and specifically looking at the yield monitor for the combine harvester. The company was established in 1969 by a gentleman called Jim Brown, who used to be a farmer. He started importing a device for measuring the grain loss on a combine harvester. Unfortunately, that product didn't work at all. But he set about developing one which did work, and he gathered together some engineers who understood electronics, and we managed to make a grain loss monitor which worked, we think, quite well. And the company was really founded on that one product. Then gradually through the 1970s we started producing speed area meters and control regulation systems for agricultural crop sprayers. We added weighing systems onto the range of instruments that measure the contents of the bucket on a tractor loader or an industrial loading shovel. And one of the products that we've always been interested in is the yield monitor for a combine harvester. At the time we were developing that, gradually positioning systems, GPS systems, were becoming more reliable, more widely available and more affordable. And everything just worked out at about the right time that we were able to develop a yield monitor for a combine harvester and add to it global positioning to record data about yield relative to particular location in the field. Okay, in the 1980s we were approached by the Claas combine factory in Germany to work together with them on developing a grain yield monitor for the combine harvester. At that time we had a yield monitor which measured the quantity of grain being discharged from the grain tank, but if, as was our ultimate aim, was to produce yield maps, we needed to monitor the quantity of grain that was going into the grain tank, which means we had to monitor somewhere on the clean grain elevator or in the combine. So we looked at a system together with Claas using an optical sensor which was looking, a light beam, looking across the paddles of the grain elevator. And as the paddles of the elevator went up the elevator, the paddle broke the beam, the infrared light beam, and the length of time the beam was broken was proportional to the amount of grain sitting on the paddle. There's a lot of advantages to this system. It's extremely simple. That's a very simple sensor to install. We just make very few modifications to the combine. Just a 20mm diameter hole in either side of the elevator. It can go onto literally any type of combine. We haven't found one that cannot be fitted yet. There's very little mechanical change. We don't have to remove parts of the combine. And the simplicity is one of its main benefits. The other sensors that we have to use in the system, obviously a forward speed sensor to measure the distance the combine is travelling and measure the forward speed. We use a switch on the header trunking, so we know when the combine is in work and when the combine is lifted out of work. We use an inclinometer on the frame of the combine to measure the angle of the combine is working, and that the angle will affect the way the grain sits on the paddles. And so we have a compensation for the angle of the combine. We use a moisture sensor because that's part of the information that's required on the yield monitor. It's not essential, but it's useful information, and generally people are expecting to see moisture on a yield monitor. So again, just emphasize the fact that the simplicity of this system is one of its great advantages. There are people who say, well, we're measuring volume and not weight. It's questionable about whether an impact plate is actually measuring weight. I would say it's not measuring true weight, it's measuring force of grain impacting on it. There are pros and cons of both systems, but ultimately we're trying to get as close to weight as we can. So with this system, it is necessary to measure the density of the crop during the day, the hectolitre weight, and to enter the hectolitre weight onto the display of the instrument, which is something that is regularly done by the operator. The data on this instrument is recording on an SD card integral into the instrument. The mapping data is recorded in an absolutely standard format, which we make that format openly available to anyone who wishes to use it, so that the yield maps can be produced and interpreted by a wide variety of software types. We prefer not to supply that office software because people have a wide variety of requirements. Some people just want to see a simple yield map, some people want to integrate it with soil maps, overhead satellite images and so on. So we just provide the raw data, we make the data format openly available, and anyone can then take that data and produce yield maps from it. So the instrument we have here is primarily a yield monitor for a combine harvester, but we have all the vital elements to do other things as well. And we can add extra software modules in the back of this instrument, so we can use the same hardware, transfer it from the combine to the tractor, and use physically this same device for mapping field boundaries, mapping waterways, mapping problems in the field, or we can put an application instrument software into it and use it for controlling the fertilizer spreader or sprayer or seed drill.